Good morning. So welcome to our first session. What I'd like to clarify today is what I would expect from you guys to complete this week. Since we had a high volume of absences on Friday, I want to make sure that everybody has had a chance to go back and take the notes and practice graphing vertex form in order to complete today's exercise, which is a review for everybody else who also was there on Friday. But more than anything, before we get that far, I want to just say good morning and hope everybody's doing well. And today, again, I'm not trying to inundate you with work. I just want to get you guys caught up for today. Starting next week, we'll get more into more practice and more depth. So for today, two things need to happen. There's a video that I posted, an introduction to parabolas. It's about an 8-minute video. I want you to watch that. Making sure that all your Friday work is done, because I also put a video up for that. And then, so the video from Friday, the notes from Friday, the practice from Friday, that type of stuff should be done first. Then today I posted the Google Classroom parabolas, intro to parabolas. It's an 8-minute video, like I said. Then after that, I just want you to complete the graphing quadratics and vertex form practice, which leads me to this. So let's take a look here. All right, so for those of you guys that were absent, this is another way to help you understand how to graph parabolas. So we've already talked about the quadratic function in vertex form. So let me see. If I went ahead and just showed you here, we have y equals a, sorry, this thing's like not a stylus. I'm using my mouse. X minus h, that's an h, squared plus k. We know that our vertex is at the opposite of whatever h is, and k stays the same. So as an ordered pair, this becomes our x, this becomes our y. Okay, and that's our vertex. So you'll see the vertex at h comma k, not x comma y, but it's the idea. So opposite of a negative h is a positive h, and k, whatever that value, will stay the same. So here, when I write my vertex, it's the opposite of h. The opposite of a positive 2 is a negative 2. And the negative 1 on the outside is your k value, and that stays the same. So essentially what we're seeing here is that this is your x comma y, which together make your vertex. And that's why you'll see it more often as h comma k. Yeah, forgive me. Let's see here. All right, so look at my hair. It's like doing this funky thing. Oh well. So all right, so that's that. So this is going to be my a value. The negative says that my parabola opens downward, which we've already talked about in your foldable. If a is positive, it's happy. If a is negative, it's sad, it opens downward. So here we go. We're going to start with graphing the vertex and then our line of symmetry. So now the next thing is the axis of symmetry. Your AOS is at x equals whatever the h value is here. So if this is a negative 2, then this is a negative 2. Okay, so I'm going to go ahead and we can't graph the line of symmetry on this, but if you were doing the practice worksheet, that's one thing you'd want to do. You'd start with getting the vertex. That would be step 1. Step 2 would be draw your line of symmetry. This would be your step 2. Step 3 would be to graph your a value, which is a negative 4 in this case. Okay, so your a is a negative 4. So whatever a is, put a 1 under it. Meaning we graph rise over run. So it's always going to be a unit of 1 from the vertex. You're never going to run 2, 3, a half. It's always going to be a 1. And this part only works from the vertex over 1 down 4 one time. After that, you need to find another value to graph. So again, that is not constant. You could see it's not constant. It's got a curved shape. So you could only do it from the vertex out one time. So with that said, I'm going to go ahead and graph this. So this graph says that I'm going to go opposite of x. So instead of going right 2, I'm going to go left 2. And then -1 tells me to go up or down, and this tells me to go down 1 unit. Okay. Now I'm going to grab this next point and plot this for my a value. Okay, so now I'm going to just focus on my a value, which means I'm going to go down 4 because of the negative and over 1. So from the vertex, here's my vertex, assuming it's there. So from the vertex, I'm going to go right 1, down 4. Again, that was from the vertex, right 1, down 4. Okay, you're always going to go over 1, down 1. Sorry, over 1, excuse me. And then this is the down 4. Okay, so now we can go ahead and I'm going to hide all of this work for a minute, and I'll show you again at the end. And I can go ahead and check my work. Let me zoom over here. And I could check it. What did I get wrong? It's over 1, down 1, 2, 3. Ah, I see. Just kidding. So be careful. Don't make that mistake. But if you do, you can easily correct it. Okay. So things like that happen. Not a big deal. Okay. So if I go back, I could show my work. First thing I did was found the vertex, which is opposite of whatever's inside with x. So if it's a +2, it becomes a -2. The -1 stays the same. So I graph the vertex from the origin, left 2, down 1. Once I put the point there, I'm going to grab the other point and graph my a value. So from the vertex, I went over 1, and I should have gone down 4, but I just didn't realize I had gone down 3. My bad. So that's the recap on graphing in vertex form. You can always pause this video to get caught up if you just need to reevaluate what I'm saying. Okay, let's try another one. Okay, so again, this is another negative. So I know my a value, my parabola is sad. It's going to open downward, which means it's going to have a maximum point. My vertex is at opposite of a +1 is a -1, and 5 stays the same. I know this is something that I asked you to do as a practice to check for your understanding, but this week, today, my goal is just to get caught up with vertex form. Keep that in mind. All right, so now I'm going to go ahead and go left 1, up 5. Left 1, up 5. Okay, then I'll grab this other point and evaluate my a value. So my a is a -3. So what I told you guys with your a value, this only works one time, is it's a -3, and whatever that a value is, put a 1 under it, and that's going to be your run. So from the vertex, you're always going to go 1 to the right or 1 to the left, it doesn't matter, and then down 3. But that only works one time. So for this point, I'm going to grab it, so here's right 1 unit, and then down 1, 2, 3. Now I'm going to check it again before I hit submit, just because I don't want to make the same mistake I made in the previous one, because it does get kind of small. So I'm going to go right 1, down 1, 2, 3, and that looks about right. Okay, so I would say that at this graph, this highest point is at a maximum value at that value of y. Y is 5. So the maximum height is 5 feet if you see it in the vertex. This is the highest it goes. So again, it has a maximum at y equals 5. So, and the calculator is if you want to try to get another point. So for example, it looks like it goes at f of 1 is 7. I'm going to test that just to be sure. So at f of 1, this is if you're graphing on the worksheet and you need more help finding out how to get another point. So since I have values at 0, values at -1, values at 0, I'm going to see the next point over to the right would be f of 1. So I'm going to test f of 1. By doing so, I'm going to get y. But that's what it looks like it is. F at 1 is 7, but I want to show you guys how you would get the 7. So I'm going to plug 1 in wherever I see an x. So I'm going to go a -3. I'm going to test x is 1 plus 1, because I'm assuming this is more for practice if you're graphing the worksheet. So I'm just kind of showing you guys how to do it. So 1 plus 1 is 2. So you get 2, I'm just going to put that in here. 2 squared is 4. 4 times a negative 3 is a negative 12. Plus 5. And that equals, oh, look at that, see, a negative 7. Got the negative. All right, so that kind of helped me out just to remind myself it's a negative 7. So x at 1 is negative 7. So when you're doing your worksheet, you're going to end up with these 2 points and the point over here because you're going to draw the line of symmetry. So if this is 1 unit in, you go 1 unit out and you'll see there's a point here. So you would need one more point, and the way I told everybody on Friday to do it is to look at the 2 outer points and go 1 point to the left and check what x is at negative 3, or 1 point to the right of the lowest point and you have a 1, or the highest point depending on if it's opening up or down. So this is an example of concave down, and you could see obviously why it's called down. So again, let's check our answer. Yay, we did it. Okay, so I'm going to go ahead and close that and do one more with you guys. All right, so now this one opens upward because it's positive. So my vertex, I'm going to click this button, go here, and then so my vertex is at, opposite of a negative 2 is a positive 2. And then k is a negative 6. All right, so I'm going to go from the vertex, I'm going to go right 2, down 6. Notice how this 4, when it's a whole number greater than 1, or just non-fractional values, if it's not a fraction, it's going to get stretched like a rubber band. So, let's see here. All right, so a value, 4, it's getting stretched. Fractions, you'll see it getting compressed, smash. All right, so let's do that. Now our a value is 4. So 4, that means I'm going to go, instead of down 4, because it's positive, I'm going to go run 1 unit to the right of the vertex and then up 4. So here's my vertex. I'm going to go 1 to the right and then up 1, 2, 3, 4. So I'm going to grab this and I'll show you. This is 1 unit to the right and going up 1, 2, 3, 4. And now, literally, if you were using a worksheet, you draw your line of symmetry and use this point to get to the middle, and then you'd go 1 point out. Every point is symmetrical, but that rise over run only works 1 time, over 1, up 4, okay? So, it looks like at the next point out, you would test 4. 4, f of 4 is 9, okay? So just to give you an idea of that, it looks that way. All right, so I'm ready to go to submit my work. I'm going to check it. Okay, we got it. Try another one here. Last one. I know, I'm the worst when I do your work. All right, so this one's interesting because it's kind of like this. You're like, wait, how do I get the opposite, right? So it's like this. X minus, since there's nothing happening with x, we're just going to do this. And then go minus 5. Okay, so if that confuses you, you can always expand it like this, but think about it, there's nothing happening with x. If I went x minus 0, that would be x, and so x squared just gives you this x squared times 2. So when there's nothing happening, when the vertex does not shift left, does not shift right, that's why it's just by itself. There's no horizontal shifting. This graph is going to go down 5 and get stretched vertically by a factor of 2. So our x value is 0, and the y value is a negative 5. So this is your h comma k, opposite, same. So there's no opposite of 0 is a 0. So 0, negative 5 comes down, and now I'm looking at my a value, which is 2. So my a value is 2. It's kind of a pain, and we're always running 1. So let's see here. We're going to go from the vertex, just the same. We always run 1 from the vertex to the right or to the left, it doesn't matter. But since this green point is here, I'm going to go to the right 1, and then I'm going to go up 1, 2. So to show that one more time, I am 1 unit to the right of my vertex, and then go up 2. Whoops, sorry. So 1 unit to the right, up 2. because my A value is 2 and I just put a 1 under it to know how many units to run to the right. It's always 1 though for quadratics. It's not constant, it's not linear like linear functions are. All right, so I can go ahead and check my work. Yay, so we did well. And then it should give me a summary. Okay, 3 out of 4 correct. All right, so that's pretty much what I'm looking for, a minimum of 3 out of 4. So try to achieve that. That'll be that. All right, so again, today's assignment, please get caught up with Friday's assignments, graphing, etc. If you have any questions, please comment underneath that assignment, and I will do my best to create a video to show that part that you have a question on, and then watch the intro to parabolas again one more time. It's an 8-minute video, and then you guys can complete this practice. And I'm going to be, for today, just hold on to your work, and we'll follow up on Tuesday. Okay, actually tomorrow's office hours, Friday, so if you have any questions between 9 and 10:30, I'll be available. But more than anything, just reach out to me if you're really struggling, and I can definitely maybe go live with you and help you in any way that's possible. Okay, so you guys have fun, and don't stress, just take it easy, and we're gonna kind of get back into it next week after you guys are all caught up. All right, have a good day.